Okay, class, this video is going to be a little bit of an explanation on couples and reactive couples. So the first thing you need to remember in this type of work is that the only thing that can cancel a couple is another couple. Okay, so forces don't cancel couples, moments don't cancel couples, you need another couple. And we've talked about the simpler problems regarding couples previously. This is a example from the textbook. It's example 2.13. And you can see here that we have a rack to hang a bicycle from a wall. We have 10 kilograms going down here. 10 kilograms is going to produce 100 Newton force. And then we have our measurements. So the first couple that's going to happen, you can see from our free body diagram here what's going on. So we're going to talk about what's happening with this couple. First of all, we take our weight, our mass, and our mass was 10 kilograms. And we know that weight, which is a force, is equal to mass times gravity. So our weight is going to be our mass, which is 10 kilograms, times our 10 meters per second squared, which is our gravity. So we get a weight of 100 newtons. And that's how they got this value here. Then you notice that they've, in the free body diagram, drawn 100 newtons going up. That is because if this is pulling down, the only thing that's going to stop this whole bracket from sliding down the wall is a reaction force going up. And that's why we have that 100 newtons that's here. So we've now got two forces that are equal and coplanar and parallel. Same direction, different sense. So that is a couple. And that couple is going to want to make this whole thing spin this way. But it's not spinning that way, obviously. So there must be another couple stopping it. And the other couple is coming from this bolt and bracket on the wall. So what you need to do is you need to say to yourself, well, this whole bracket's wanting to spin around in this direction. Okay, so it needs to have something that's going to stop it by spinning in the opposite direction. So the bracket's wanting to come away from the wall, so we have a horizontal force being provided by the bracket and the bolt into the wall, and we have to balance that force with another one because we need a couple to make that happen. So we have the equal and opposite force going that way. Okay, so that's the way you have to imagine it. This bottom of this bracket is pushing into the wall, and this is pulling in. So pulling in and pushing away, but to balance the other couple. So you've got a couple and you've got another couple. This is the active couple that I'm drawing now. Active couple, and then we've got the reactive couple at the wall. So RBH is the reaction of the bolt. So RBH is reaction of bolt horizontal. Because what's happening is the bracket wants to pull away from the wall, so we need this horizontal force to hold it up against the wall. And it's balanced at the bottom by the reaction with the wall equals reaction at the wall. So this couple here wants to make the whole thing go the other way, and that's the thing that balances it. So we can now look at our working out for this type of problem. So I'll just move the page up a little bit. We'll keep our free body diagram in view. First thing too is you'll notice that they haven't converted these units, and I always advocate converting units in your free body diagram. So that's going to be 0.32 meters, and this is going to be 0.08 meters because we divide by 1,000. So let's work out what our forces are now at the wall, the reaction at the bolt horizontal. We don't know it yet, but we do know that if we take our reaction of the bolt horizontal and multiply it by our distance, which is 0.08 meters, which is this distance here. That's a couple, that's the reactive couple. And we said that the couple has to balance the other couple. We know the other couple is our 100 newtons, because we only use one force when we're calculating the moment of a couple, times 0.32 meters. So, and that's all because we know our formula, moment of a couple is equal to force times distance. Okay, so that couple, force times distance, has to equal this couple, force times distance. And when we make RBH the subject of this equation, because the equation has to balance, so if we divide by 0.08 on this side, we have to divide by 0.08 on this side. So we end up with 32, because 100 times 0.32 is 32, divided by the 0.08, which we got rid of here, and we end up with a force RBH is equal to 400 newtons. So even though we've got 100 newtons pulling down here on the bike bracket, at the wall the bolt is actually having to pull out 400 newtons. Okay, there's 400 newtons pulling this way because it's a shorter distance between the two forces for this couple, the reactive couple. So it has to be bigger to balance it out. Okay, so you're not at your answer yet, because for this question they're asking for the reaction in the bolt. So I'm just going to rub out here so that we can explain how that reaction at the bolt works. So we'll just grab a rubber and we'll just rub out all of this business here, and we'll just make it a little bit clearer as to what's going on. Okay, so we've established we have 100 newtons going up, and we have coming this way 400 newtons into the wall. And they're asking for the reaction at the bolt. The bolt has two forces acting on it. It has a 400 Newton force going this way into the wall, and we also have a force acting up to stop the bracket from sliding down the wall. So we can take that, and we know that we want to add to find our resultant force, because we have two forces acting on the bolt, one horizontal and one vertical. So the resultant is going to be that 400 newtons plus the 100 newtons. We add our vectors tail to tip, and then we have our resultant. So our resultant, I'm going to call that resultant of the bolt, is equal to the hypotenuse of this triangle. And we know that when we're trying to find the hypotenuse for a triangle, we need to use Pythagoras' theorem. So RB, the resultant of the bolt, is going to be the square root of 400 squared plus 100 squared. And we end up with the resultant for the bolt. If we do the maths for that, the resultant of the bolt is going to be equal to 412.31 newtons. So that's our resultant of the bolt, but we still need to, because it's a vector, we need to have a direction as well. So we need to calculate. I'll show you where that resultant is for the bolt. In this drawing here, it's going to be there. Okay, it's going to be a resultant. Oh, sorry, it's going to go up to here. Okay, so that's your resultant of the bolt. So we need to calculate this angle here, which is in this triangle is here, and that's going to be equal to tan theta is equal to, because we're trying to calculate, we know that tan is equal to opposite over adjacent, so car toa. So we're going to be adjacent over opposite, sorry. So I always get this wrong, don't I? Our tan is going to be equal to, opposite over adjacent. Toa, see? Toa, opposite over adjacent. So that's going to be equal to the 100, which is here, over the 400, which is here. So tan is going to be equal to, and I'll just rub that out, 100 over 400, which is equal to, theta is going to be equal to 14.04 degrees. Okay, so we've now got our vector magnitude and our vector direction. So to write that answer correctly, what you might want to do is just write reaction of bolt is equal to 412.31 newtons. Don't forget your units, and then you draw your bottom of your triangle and you write in here 14.04 degrees. You'd want to write it in there. So that's your answer, and that's how you do this type of question. Okay, have a go at a few examples. The main thing you need to remember is that a couple can only be cancelled by another couple. You need to establish your two couples, find the force that you're missing, and then resolve for horizontal and vertical forces. There's 3 or 4 steps in this process, but if you practice the steps, you'll be able to answer this type of question. A lot of these questions, it's all about understanding the concept and understanding the steps to get to a solution. Hope that's been helpful. Any questions, please do not hesitate in contacting me. Thank you.